Solving polynomial equations. But again, we already know some polynomials. So let's just review some of the hopefully easy stuff. Multiply to 8, add to 2. So plus 4 minus 2. So x is negative 4 and x is 2. Like that's, what's that, algebra 1 stuff? Definitely algebra 2. Factoring this guy would be a little bit harder, right? This is where people start getting confused. Because, let's see, I'm still going to guess and check. If you have your own method of, like, teachers teach some wacky stuff when they teach factoring. Like, there's magic boxes, and there's a giant X, and there's lots of goofy stuff out there. If you use one of the goofy methods, that's fine. I'm not going to be able to work with you on the goofy method, though. So if you come in and ask me for help, I will be happy to help you, but I will not know whatever silly thing that you learned to help you factor. I don't mean to talk down on those methods, but you need to be able to guess and check and figure it out. So factors of 1, that's easy. That's got to be 1 and 1. And then factors of 6, well, it could be 1 and 6, or it could be 2 and 3. But if I want minus 1 in the middle, then it seems like 3 and 2 would be my best shot at getting there. And then, oh, the double smiley face. Some people talk about that. That's not really a method. That's just to remind you to check for the middle term, or how to check for the middle term. I want it to be negative, so I need a negative 3x and a positive 2x. There we go. So x equals negative 1/3 and x equals 1/2. All right, but that's the easy stuff. That's the review stuff. We already know how to do that because those are quadratics. Now, I did those as examples, not so much to remind you, but to let us know that they do give us some hints about the higher polynomials. So some of this factor stuff, multiply to that last number, factors of the last number, factors of the first number. There's some stuff going on behind the scenes there that we can apply to cubic, quartic, quintic, on. And there's a way to get the possible rational zeros. Which, I don't know, I've always, when we teach this, it's like, well, is that helpful? Because like I want to know what the zeros are. I don't care what the possible ones are. But this at least narrows down your guesses when it comes time to get the zeros. In fact, I think let's just say it what it is now instead of working our way there. The possible rational zeros are the factors of the last term divided by factors of the first term, and plus or minus on all that. So just like when we were factoring, we had to think about the factors of the last term, we had to think about the factors of the first term. This kind of helps guide us and give us, our possible things that will work. And then we will guess and check to see which one works. So I'm going to skip this explanation stuff. So let's find the roots of this function. I'm going to just rewrite it here so I'll have it to look at. It'll be on screen. So finding the roots of that, like how am I going to, where would I even start except at my possible rational zeros? And we usually don't write them all out. You can if you want to, but this would be, actually let me just slow it down a little bit. Factors of 6 over factors of 1. So I like the factors of 1, right, because there's only one option there. So plus or minus 1, 2, 3, or 6 over 1. So think carefully before you answer this. How many possible rational zeros are there?
8.
8, right? Because the plus or minus on there. So 4, but plus or minus means there's 8. Now, to check to see if, like when we say guess and check, we'll use synthetic division. Because if we get a 0 at the end, it means it worked. If we don't get a 0 at the end, well, we try something else. So, I mean, I know what to try because I've got the answers, but just starting, we don't know what to try, so I'm just going to try 1 and see if it works. By see if it works, what am I looking, how will I know if it works? What am I looking for? If it sort of ends in a 0, if the remainder is 0. So I'm checking if x minus 1 is a factor by synthetic dividing with 1. So you're going to need to be speedy at synthetic division. Speedy, but without making a mistake. So that's a no. That one didn't work. So some people this is frustrating because there's no way to get the answer other than to guess and check. Well, let's guess another one. What do you think we should guess? So plus 1 is out. I'll try 2. Okay. Bring down the 1. 1 times 2 is 2. 2 plus 2 is 4. 2 times 4 is 8. 8 minus 5 is 3. This is going to work. 2 times 3 is 6. So we get 0 at the end. Yes, that means x minus 2 is a root. Or is a factor, excuse me. X equals 2 is the root. X minus 2 is the factor. So that means f of x is, so I've got x minus 2 works, and then I can use these sort of reduced coefficients. It's actually called a depressed polynomial. Again, not comment on its mental state, but the fact that it was cubic and now it's squared. And the good news is, once you find 1, then you can deal with you can use the depressed coefficients. You don't have to go back to the original. You can start working now on the new polynomial, the new depressed polynomial. And now that we're down to a quadratic, I mean, you can keep guessing, but I don't need to guess anymore because I can factor what's left. X plus 3 and x plus 1. Now, if you want to keep guessing on the reduced coefficients, you can, but once you're down to a quadratic, there's no need to. Okay, so there it is factored, but what did this say to find? It said find the roots. So x equals 2, x equals negative 3, and x equals negative 1. Which means sort of my other best option for a guess was going to be negative 1, and that one would have worked as well. Now, depending on how terrible the function is, you might get, 5 or 6 things in the top factors and maybe 2 or 3 things in the bottom, and then you got all sorts of combinations, and it's just going to be a pain. You're just going to have to guess and guess and guess until 1 or 2 of them hit, and you get down to a quadratic, and then you're good. So this one was pretty easy because we had a limited number of guesses, and we got our first one on the second guess, so it wasn't bad. But this is maybe not representative of all of the problems. All right, we kind of jumped the gun by me just telling you what the possible rational zeros are. So for this one, so plus or minus, factors of last, 1 and 3, factors of first, 1 and 2. Now this one would be a little bit harder to just come right out and say how many there are. Some of you could probably figure it out. I'm going to list them out. So plus or minus, and I don't know if this is like official math but I don't want to write plus or minus a bunch of times. So I'm going to put the plus or minus out front. And 1 over 1, 3 over 1, 1 over 2, and 3 over 2. So that's 8 possibilities. And it was only a cubic, so if I was really bad at guessing, in theory I could guess 5 wrong answers before I finally got one that worked. That would just be bad luck if it happened that way. I would try 1 first, and then 3 or negative 1. Like, try the easy ones first, and hope that you get one. All right, that box is the official way of saying what I just said. The possible rational zeros are factors of last over factors of first. So I'm not going to, let's just jump to number 5. Find the zeros of that thing. Okay, actually before we get started, how many zeros are there of that thing? 3. So I know there's 3 answers. I can't factor that. I mean, I could try, but it doesn't look good. So possible rational zeros, plus or minus. Is this the same one we were just looking at? Because factors of last are 1 and 3. Factors of first are 1 and 2. So my possibilities are 1 and 3, 1 over 1, 3 over 1, 1 half, and 3 halves. And all of those could be plus or minus. So yeah, I got 8 guesses. Well, I don't know what to guess. So I'll guess 1, and we'll see what happens. Again, lots of synthetic division practice today. Bring down the 2, multiply, add, multiply, no. So negative 1's out. All right. What do you want to try next?
3.
All right, I heard 3 and I heard negative 1. I guess I'll go with 3. Bring down the 1. Whoops. So I'm testing 3, which means I'm looking to see if x minus 3 is a factor. Multiply.
Wait, why would it be 1?
Wait, that should be 2, yes. That was going to get me a wrong answer in a hurry here. Bring down the 2. 2 times 3 is 6. Minus 3 is 3. 9, 1, 3, 0. Yes, good news. So x minus 3 is a factor. And now I'm down to a quadratic. So whether it factors or not, I don't care. I can solve from here. Because I could use the quadratic if it won't factor. But I think that'll factor. All right, 1 and 1, 2 and 1. I'm factoring pretty quick. I'm assuming if you're in Pre-Cal BC, you can factor without trouble. If it's trouble factoring, it's going to be a long year. So x equals 3, x equals negative 1 half, and x equals negative 1. Our second guess, I went with 3. Somebody had said negative 1, and so negative 1 would have worked as well. I wouldn't try the fractions until you ran out of the integers. But if you had guessed negative 1 half, it would have worked. Find all the zeros of x to the 4th plus 5x squared plus 4. So how many zeros are there going to be? I don't know what I'm looking for. So it should be 4 zeros total. I'm looking at that thing and I'm thinking, wait a minute, I don't I think I can factor that. I don't have to do the possible rational zeros thing and go through all of the options. I think I can factor that. Right, the fourth looks crazy, but if I go x squared and x squared, then I've got x to the fourth. Excuse me. And I could go 4 and 1. Plus 1 plus 4. The middle term would work out for me to be 5x squared. So you don't always have to do the possible rational root with synthetic division. Like if you can tell it factors and you can factor it, then by all means factor it. So set both of those equal to 0. Uh-oh, what's about to happen here? I. So when I square root both sides, when I square root a negative, I'm going to get an I. When I square root both sides, I got a plus or minus. So plus or minus I. Sometimes people will forget the plus or minus. Other people will forget the I, but have the plus or minus. Be careful. X squared equals negative 4, so x equals plus or minus 2I. So a couple of comments here. First, how many answers is that? 4, because you got plus or minus on both of them. So I found all 4. How many of my answers are, well, phrase it this way. If we had done possible rational zeros, so that would have been 1, 2, and 4 over 1. This is why they're called possible. They're not all, like it doesn't cover the imaginaries. So if we had gone this route, we would have tried all 6 of those and none of them would have worked. And that would have been very annoying, right? To work through all of them and then realize none of them work. So I guess the moral of the story is if you can factor. The possible rational roots things is nice, but it's kind of a last resort. Like I can't figure out what's going on here. I'm just going to guess and check and see what works. Irrational roots come in conjugate pairs just like imaginary numbers do. Okay, so we've already talked about imaginary numbers coming in pairs. 3 plus 2i, 3 minus 2i. But irrationals come in pairs as well. So like 2 plus square root of 5 and 2 minus square root of 5. So that will help as well once we get going. So this quadratic, well, we can do this one. 0 equals 9x squared minus 2. So 9x squared equals 2. So x squared equals 2/9. So x equals plus or minus square root of 2 over 3. I'm going to go ahead and square root the bottom. But those are conjugate pairs, that plus or minus thing. Another place the conjugate pair thing shows up, x equals negative b plus or minus the square root. Plus or minus the square root. The plus or minus means conjugate pairs. So all that to say, number 7, p of x is a 4th degree polynomial with roots of square root 5 and 7i. Write p of x in standard form. We did some that were very similar to this yesterday or Wednesday. So if 7i is a root, what else is a root? And if root 5 is a root, then negative root 5 is a root. So there's my 4 answers. So x plus root 5, x minus root 5, x plus 7i, x minus 7i. So that's almost done, but it does say standard form. So I got to multiply it out. But it's not too bad because the conjugate pair things will make things go away. So x squared minus 5 times x squared. Oh, let's be careful on this one. What do I get when I multiply x plus 7i times x minus 7i?
7i squared minus 7i squared.
So I get
Or 49.
minus 49i squared,
Which is plus 49.
also known as plus 49. Still not there. I need to multiply those, but now the roots and the square root stuff is gone. So x to the fourth minus 5 plus 49 would be plus 44 x squared minus 49 times 5. Well, 50 times 5 would be 250, so 5 less than that. Or come to the side and do 49 times 5 your old school way here. Yep, 245. So, a little bit of algebra, but the pre-cal part of the problem was the conjugate pairs. Number 8. Multiple choice. Should be okay here. The graph of f of x is shown. Which of the following must be true? F has an absolute minimum but no absolute maximum. What do we think? Yes, like there's the absolute minimum. But no absolute maximum because there it goes up forever. So yeah, that's a true statement. There is a minimum, there is not a maximum. F is a 6th degree polynomial. Well, both ends are doing the same thing, so that's even, so maybe. Let's count the roots. There's 1. How many is this? It's 3, or, well, actually I'm not even convinced it's 3, but it might be 3. It's at least 3, maybe put it that way, right? Because it does the wiggle thing. And how many roots is this? 2, maybe. It's at least 2. All right? There's no scale here, so I don't know if that's 2 or 4 or 1,000. It's probably not 1,000, but I don't know if it's 2 or 4. That could be 3, but it could also be 5. So is it a 6th degree? Well, the answer is maybe.
What says not true?
In fact, I would say likely even. But must be true? No, it doesn't must be true. So 2 is out. But 2 is tricky because it's probably 6th degree. It might be 6th degree, but it might not be 6th degree. F has 3 points of inflection. Okay, inflections are where it changes from, bold up to bold down or vice versa. So let's see. We're smiling versus frowning. Smiling. Somewhere in here, we switch over to frowning. Yes? Frowning. Oh, right here we switch to smiling again. And then somewhere in here, we switch to frowning. And we're frowning till we get over here. And then we switch to smiling, and we're smiling the rest of the way. So, no, it does not have 3. It has 4. So 1 only. Are you okay with the inflection points, though? And again, we don't really know enough to locate them exactly. We just know that somewhere in there it changed from being concave up to concave down. Number 9. Find all the zeros. How many zeros are there? Find all 5 of the zeros. Yes. If you can factor that on your own, knock yourself out. I got no idea. So I'm going to have to do the possible rational zeros thing. So factors of the last. 1, 3, 9, and 27. Factors of the first, or at least I catch a break here. There's only one of those. So how many possible factors are there? 8. And again, it doesn't mean that any of those 8 are really going to work. Now, hopefully they do, because of this, the way this problem's set up. It'd be a terrible problem if none of them work. Start with the low ones. So I'm going to start with 1. Try to write small because guess and check. Double check to make sure you got all the coefficients right. You'd hate to do all the work from a bad starting point. Okay, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, and no. Okay, well, 1's off the list. Guess and check. Let's try -1. Bring down the 1, multiply, add, and it's hard to see if you're going to get anything until it gets to the end. Like, you don't know 2 or 3 steps in if it's going to work or not. Although I'm getting suspicious here with -74, +74. Okay, at this point, 27 plus 74, I don't know, really big. Multiply, this isn't going to work. So, I mean, we can keep going if you want. That'd be 101. But yeah, this is a no. So feel free to bail out whenever you can, but you really can't know for sure until you get kind of close to the end. Crud. 1 and -1 are out. Let's try 3. I was about to ask if anyone had found one that works. Cade says 3 works. I hope so. Multiply, add, multiply, add, multiply, add. Again, be super careful, because if you mess something up along the way, then you won't know if it works or not. Alright, yes, we got one that works, finally. X equals 3, or x minus 3, however we want to say that. Okay, so yay for us, I guess. Now I'm down to a quartic, so at least it gets easier once you find one. 1, -6, 10, -6, 9. Shoot, 1 and -1 are already out. I can't, like, they're not going to work. I tried 3. Try -3. Again, I'm trying on my reduced coefficient, so at least once you find one, it gets easier. Somehow, like, make a note once you find one, like, don't forget we found one. X equals 3 is good. I may come back to that later. I will come back to that later. So trying -3. Uh-oh, this isn't looking good, because 37 times 3 is 90 plus 21. 111. Negatives. Yeah, this, I'm just going to bail on that. Say no. I don't really want to try 9 and 27. What I could do is don't forget about repeated roots. So let's try 3 again. So it's, it's not really fair to say there's 8 guesses. There's 8 guesses, but there could be repeated roots in there. It'd be funny if they were all 3. That'd be... let's see. Whoops. Copy down the 1. I get 1. 1 times 3 is 3. Multiply, add. Multiply, add. Oh, this is looking good. Yes. So x equals 3 works twice. And I'm down to a cubic, which there's no guarantee I can solve a cubic, but look at those coefficients. Like, I think I can factor that by grouping. So if you can't factor it by grouping, then you got to try again. If you can factor by grouping, then we can be done. Are we okay factor by grouping? So because the coefficients are the same, otherwise I'd have to guess one more. But I think we lucked out on this one. So we factor out an x squared, that leaves x minus 1. Factor out a 1, oh, excuse me, that leaves x minus 3. Factor out a 1, that leaves x minus 3. And so x minus 3 and x squared plus 1. But don't forget, there's still 2 more x minus 3's that are factors. Okay, so I've got it factored all the way, but read the question, make sure you answer the right question. I guess it could have said just factor this, but it said find the zeros. Okay, no big deal. X equals 3 as a triple root, and x equals plus or minus I. Because we move it over, it becomes negative 1. So this is one of those, how many zeros does that have? Yeah, it's like, I'll accept 5, I'd accept 3. So I'd have to word the problem, carefully. Total zeros, 5. Unique zeros, 3. I probably won't be asking that question because you could defend either answer. But don't get confused. We started out looking for 5 answers. We have 5 answers. We just happen to hit a triple root. So it's kind of a pain. You got to just guess and check till you get one, and then don't forget you can check again for double roots. All right, last one. Yes, last one. Which of the following is false? Has exactly 1 real zero. I don't know just by looking at it. It's got 3 total, but I factor out. So it definitely has x equals 0. That won't factor. That doesn't necessarily mean it has imaginary, though. It does mean I'll have to use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So it does have imaginary. It wasn't guaranteed to have imaginary, but it does have 2 imaginaries. So it does have exactly 1 real zero. Well, all that work and all we can say is, yep, that one's true. Keep working. All cubic polynomials with integer coefficients have at least 1 real zero. There's a couple ways to attack that one. 1 real zero. If it has an imaginary zero, it can't have 1 imaginary zero, right? Because they come in pairs. So it has to have, if it has any, it has to have 2. And if it has 2 imaginaries, then it's got to have 1 real. I suppose it could just have 3 reals if it didn't have any imaginaries. So that's true. The other way to think about that one is to think about the graph of a cubic. And because it goes forever up and forever down, it's got to cross the x-axis somewhere, right? And maybe it crosses it 3 times. Maybe it only crosses it once, but it definitely has at least 1 real zero. 12 possible rational roots using the possible rational roots test. I don't know, plus or minus 1, 2, 3, 6 over 1 and 2. That looks like 8 times 2 is 16, but some of these are repeated. So this is the danger of writing it like this. Let's write them all out. Let's put them all over 1. So 1 over 1, 2 over 1, 3 over 1, 6 over 1. Now let's put them over 2. 1 over 2. 2 over 2 we already have. So I'm not going to rewrite 2 over 2. 3 over 2. 6 over 2 is 3. I've already got that one. And plus or minus all that. So it is 12. So it's got to be D. X to the 4th minus 64. So yeah, you could do it that way. X squared plus 8, X squared minus 8. Yeah, so X squared plus 8 is going to lead to imaginary. X squared minus 8, you'll get 2 intercepts. I also know, I don't know exactly what X to the 4th looks like, but it looks a lot like X squared. And minus 64 just pushes it way down the, so it has 2 X intercepts. So D is it. So the main thing today is the possible rational roots. Guessing and checking with synthetic division, kind of annoying, but synthetic division goes quick. Just be careful, because if you miss one little thing in here, then you've ruled out one, and you're never going to go back to check it again, and you're going to spin your wheels. You're going to get through all of them and miss one. So this next test, if you mess up on this little section, you're really going to be spinning your wheels. All right, the next assignment is whatever worksheet is next, worksheet 5.
We get out in 10 minutes.
And we get out in 10 minutes.
See?